एंड इंसिडेंटली हमने अभी उनके जन्म के 100 साल का प्रायोजन किया था, उसका समारोह किया था 12 अगस्त 2019 को। तो 1919 12 अगस्त को उनका जन्म हुआ था एंड 2019 में 12 अगस्त में उनकी जो जन्म शताब्दी है उसकी उसका हमने प्रायोजन किया था। एंड इंसिडेंटली जो उनके बाद हमारे जो आपको पता होगा कि डॉक्टर साराभाई की मृत्यु बहुत जल्दी हो गई थी, 52 साल की उम्र में ही। तो ही डाइड इन 1971 25 दिसंबर। So he died at a relatively a very early age. Otherwise, he could have done more work related to space program. But unfortunately, he died very early. And so after him, Dr. Satish Dhawan took the charge of ISRO, and he was then director of IISC. आप सबने नाम सुना होगा, इंडियन इंस्टीट्यूट ऑफ साइंस बेंगलोर में है। भारत का एक नंबर का, अव्वल दर्जे का, फर्स्ट नंबर का जो रिसर्च लेबोरेटरी कहा जाता है वो IISc को माना जाता है। तो IISc के डायरेक्टर थे सतीश धवन साहब। ही वाज अ मैकेनिकल इंजीनियर एंड देन ही टुक ओवर ISRO आल्सो बिकॉज ही उन्होंने एक शर्त रखी थी, प्रधानमंत्री उस समय थे इंदिरा गांधी जी के सामने, कि इफ यू वांट मी टू हेड ISRO आल्सो, बिकॉज ही वाज डूइंग रिसर्च एट IISc एंड ही वाज डायरेक्टर ऑफ IISc. He had just returned from USA at that time. So he said that I want to do research at Bangalore. Then if you want me to do ISRO activity also, then you bring the headquarters from Ahmedabad to Bangalore. तो इस तरह से हमको एक काफी दुख रहता है हमेशा कि अदरवाइज PRL में जो हेडक्वार्टर था हमारा ISRO का वो यहाँ पे रहता, इसके बदले अभी बेंगलोर में है। एनीवे दैट इज नॉट वेरी इंपॉर्टेंट, बट जो सतीश धवन साहब बेंगलोर में दोनों संभालते थे, IISc एंड ISRO, और उन्होंने काफी समय तक ISRO की आगेवानी की। ही लेड ISRO's टीम एज ए चेयरमैन ऑफ इंडियन स्पेस रिसर्च ऑर्गेनाइजेशन। एंड इंसिडेंटली 2019 के बाद 2020 में हमने उनके भी जन्म के 100 साल मनाए। सो 25 सितंबर 1920 को उनका जन्म हुआ था। 25 सितंबर 2020 को, ऑफकोर्स उस टाइम पे कोविड और उसकी बीमारी चल रही थी, उसके कारण हम पूरा समारोह तो नहीं कर पाए, बट ऑनलाइन सेलिब्रेशन वी डिड that time. So 25th September 2020. So these two stalwarts were the guiding hands behind our India space program. And all of you know Dr. Abdul Kalam Sahab. He was the leader in our launch vehicle program. And all of you know about him, so I don't have to tell you, because he was such a visionary that he carried out all the activities in such a manner that he finally rose to become not only as an advisor to Prime Minister's Defense Minister, and then finally he became the President of our country. So you can imagine the capabilities and the dreams he gave. So he was always used to say, follow your dreams. तो आपको अपने जो सपने देखे हैं उसको पूरा करने में बड़ा सोचिए। So that was his vision. And नीचे जो आप पिक्चर देख रहे हैं एक रेयर पिक्चर है जिसमें डॉक्टर साराभाई भी दिख रहे हैं और डॉक्टर अब्दुल कलाम भी साथ में दिख रहे हैं। तो these were the stalwarts who pioneered the India space program. So you can imagine कि ISRO का जो नाम है उसके पीछे ये इन लोगों का जो मेहनत है, उन्होंने जो गाइडेंस दिया, मेंटरिंग किया ISRO की, उसके बदौलत हम आज यहाँ इतना आगे बढ़ चुके। This is ISRO. This is, as you all know, ISRO works under our Honorable Prime Minister. There is a Space Commission, Department of Space is there, like any other government department. There is a Department of Space which works directly under Prime Minister. And then we have 7 major centers, जो नीचे orange color में दिख रहे हैं, VSSC, LPSC, श्रीहरिकोटा, URSC Satellite Center, Space Application Center अहमदाबाद, जहाँ पे अभी मैं बैठा हूँ, that is does the activity of payload and application, NRSC हैदराबाद, and then अभी नया जो स्थापित किया गया है HSFC ह्यूमन स्पेस फ्लाइट सेंटर, जो हमारा गगनयान प्रोग्राम है उसको स्टीयर करने के लिए। दिस इज द न्यू सेंटर सेटअप राइट नाउ इन बैंगलोर। एंड राइट हैंड साइड यू आर सीइंग द वेरियस लोकेशंस ऑफ ऑल आवर campuses in different place, so you can see the buildings as well as the ambience of all this campus. That itself gives you the natural urge to do research. So हर एक जगह ऐसी जगह पे हमने हमारे जो सेंटर लगाए हुए हैं, स्थापित किए हैं, कि आपको अगर सेंटर में आप आते हो, एंटर करते हो, तो वहीं से आपको लगेगा कि यहाँ इतनी अच्छी लेबोरेटरी होगी और यहाँ पे काम करने का कोई मजा कुछ और ही है. So that is the, because many times where you work, that ambience is also very important. So the ISRO provides that ambience at different centers. And as you can see now under ISRO, there are many other small centers also. जैसा कि यहाँ बताया गया है, ISTRAC, IPRC, IISU, DECU. So this type of many small units, small centers are also there, spread all across the country. And nowadays now government wants to involve private sector, so we have set up now one Indian National Space Authorization and Promotion Center. Its headquarters will be in Ahmedabad, so Honorable Prime Minister is going to inaugurate it very soon. And then there is another public sector company that is called Antariksh, as well as New Space India Limited. So they are our commercial arms of ISRO. So they will do the commercial activity. Whatever activity ISRO does, that is more a research and development activity and doing various in national projects. But apart, जैसे कि हम प्लानिटरी साइंस के प्रोजेक्ट करते हैं, गगनयान है, मंगलयान है, चंद्रयान है, तो वो सब these are all interplanetary and other research project. बट उसके अलावा जो नॉर्मल प्रोजेक्ट है उसका भी संचालन इन स्पेस, एनसीएल, अंतरिक्ष उसके थ्रू होगा. सो दिस इज द न्यू चेंजेस विच गवर्नमेंट वांट्स टू ब्रिंग आउट. सो एंड जैसा कि मैंने बताया, कुछ ऑटोनोमस बॉडीज भी है इसरो में. पीआरएल है, नेशनल एटमॉस्फेरिक रिसर्च लेबोरेटरी है गडंग की तिरुपति के पास, फिर एनीसेक है. So this is what is ISRO. And as you can see, as I was telling, if you, wherever you are located, you don't have to worry that if you want to work for ISRO, want to contribute in ISRO space activity, there is a possibility for teachers as well as students to get involved, because we have centers almost all across the country. Some way or the other, we have set up incubation centers, then space promotion centers, and we provide research activity, research grants to various colleges and other places, research institute. So it is not necessary that you have to all the way come to my place in Ahmedabad, or you have to go to Bangalore or Trivandrum. Wherever your school is located, your college is located, you are located. If you want to contribute, you want to have understand about some of the activities of ISRO, you can always approach the nearby center, which is nearer to your place in your town or your nearby your village or city. It is possible to have. So जैसा कि आप ये मैप से ही पता लग रहा है, जो लोकेशन मैंने बताया, कहीं ना कहीं कुछ ना कुछ इसरो की एक्टिविटी चल ही रही है. सो एंड जो एक्टिविटी क्या चल रही है हमारी, लॉन्च व्हीकल रिलेटेड, सैटेलाइट डेवलपमेंट रिलेटेड एंड एप्लीकेशन रिलेटेड, जो पेलोड डेवलपमेंट है और उनके एप्लीकेशन की. फाइनली एज सारा भाई सेड, वी हैव टू डू एप्लीकेशन, बिकॉज स्पेस रिसर्च का फायदा अगर कॉमन पब्लिक को ना पहुंचे, आप लोगों को ना पहुंचे, तो उसका कोई मीनिंग नहीं है. बच्चों को उसका ज्ञान बढ़ना चाहिए, विज्ञान में रुचि बढ़नी चाहिए. तो ये सब एक्टिविटी भी इसरो करता है. कि मैंने बताया, यू हैव अपॉर्चुनिटी टू अप्रोच एनी ऑफ दिस सेंटर एंड यू नॉट कम ऑल द वे टू, नहीं तो क्योंकि नहीं तो फिर आप वैकेशन या ऐसे कोई टाइम में आ सकते हो. अदरवाइज हियर ड्यूरिंग योर नॉर्मल स्कूल और कॉलेज टाइम ऑल्सो यू कैन अप्रोच एनी ऑफ दिस ऑर्गेनाइजेशन. एंड वी हैव मेनी ऑफ द प्लेसेस वी हैव ऑर्गेनाइज द एग्जीबिशन ऑल्सो. और अगर आपकी स्कूल के लिए भी एग्जीबिशन और वो सब करना हो, मोबाइल एग्जीबिशन है, ऑनलाइन लेक्चर्स है, जैसे कि आज मैं आपके लिए दे रहा हूँ, तो उसी प्रकार के सब मैनेजमेंट भी हमने किए हुए हैं. उसके बारे में मैं बताऊंगा आपको. दिस इज इसरो. अभी तक के ऑलमोस्ट 51 ईयर्स कंप्लीट हो चुके हैं, 52 ईयर्स होने जा रहे हैं. 1969 में हमने ये सफर चालू किया था, तो 52 ईयर्स हो गए हैं. तो उसमें लगभग 175 मिशंस वी हैव कंप्लीटेड. लॉन्च मिशन 73, 102 सैटेलाइट मिशंस, एंड वी हैव लॉन्च मेनी फॉरेन सैटेलाइट ऑल्सो. और आप जैसे स्टूडेंट के सैटेलाइट भी हमने स्थापित किए हैं स्पेस में. तो कई यूनिवर्सिटी है वो अपने सैटेलाइट बनाते हैं, पर आजकल हम स्टूडेंट को सैटेलाइट, पूरा सैटेलाइट बनाने के बदले उसके जो अंदर का इलेक्ट्रॉनिक्स है, पेलोड है, क्योंकि वो जल्दी से बन पाएगा. एंड यू कैन लॉन्च इट ऑल्सो इन आवर PSLV लॉन्च व्हीकल. उसमें एक हमने प्लेटफॉर्म बनाया है, तो उसका यूज करके आप जल्दी से अपना भी कोई आइडिया हो उसको अमल में ला सकते हो. तो दीज आर ऑल द एक्टिविटीज which are possible to do with ISRO, even for the school students or college students. And of course your teachers can help you to do these activities. So these are some of the avenues open. So I will talk about that in the end also. But this is in summary. और इससे आपको लगेगा कि इसरो तो हमेशा सक्सेस ही मिलता है, ऐसा भी नहीं है. वी हैव मैनी फेलियर. जैसा कि अभी हमारा लेटेस्ट सैटेलाइट तो बहुत अच्छी तरह लॉन्च हुआ था 14 फरवरी, विच वाज वैलेंटाइन डे इस साल. तो हमने एक रडार सैटेलाइट स्थापित किया है स्पेस में, का नाम है IRIS-1A. बट उसके पहले वाला जो सैटेलाइट था लास्ट सितंबर में, तो वो GISAT-1 सैटेलाइट, तो उसको लॉन्च करते टाइम हमारे लॉन्च व्हीकल में कुछ प्रॉब्लम हुआ, तो उसके कारण दैट सैटेलाइट वी कुड नॉट लॉन्च. सो ये एक सक्सेस स्टोरी देख के आपको ऐसा लगेगा कि इसरो में हमेशा सक्सेस ही मिलता है, ऐसा नहीं है. जैसा कि हम भी परीक्षा में कभी पास होते हैं, कभी फेल होते हैं, उसी तरह इसरो को भी कई फेलियर्स हुए. बट हमारा हाउ वी आर डिफरेंट फ्रॉम अ कॉमन पीपल आर दैट वी ट्राई टू लर्न फ्रॉम एनी ऑल द फेलियर्स, बिकॉज स्पेस बिजनेस ही ऐसा है, स्पेस एक्टिविटी ऐसी है कि उसमें फेलियर तो एक्सपेक्टेड ही है. क्योंकि हम जो कितना भी सोच के सब प्लान करें, इलेक्ट्रॉनिक्स बनाए, उसके स्ट्रक्चर बनाए, बट जब लॉन्च होने के टाइम और लॉन्च होने के बाद क्या होगा, कई चीजें हम अभी से एनविसेज नहीं कर पाते. So all these things result into many times failure. So we have to accept failure also in our stride and try to learn from that failure. So the next time we don't make same mistake. So that is the major reason behind ISRO's success, is that there are many failures, but at the same time we try to learn from failure. So ये आपको भी ये मंत्र आपके जीवन में रखना है. Teacher should cultivate this and try to inculcate this into the students also. That one should not get worried or disheartened from failure, because failure is part of life. जैसा कि हमारी इसरो की प्रोफेशनल लाइफ में failure is a part of the story. Same way any person's life also failure are bound to be there. कभी हम स्कूल में अच्छे नंबर नहीं पाएंगे, या कभी इंटरव्यू में अच्छा नहीं कर पाएंगे, नौकरी में सिलेक्शन नहीं होगा. तो all these things are failure, but we have to learn from this failure and then move forward. So that is the basic idea which I want to convey. This is my space application center Ahmedabad, where we do all this satellite communication and navigation activities. I will tell you about that. ये जो आप देख रहे हैं, ये जो बिल्डिंग राउंड टाइप का, और ये बड़ा एंटेना है जो 14 मीटर का एंटेना है डायमीटर. और ये जापान की कंपनी NEC, आपने सुना होगा नाम, निप्पॉन इलेक्ट्रिक कंपनी, उससे बनाया था ये 1965 to 69 टाइम फ्रेम में. और उस टाइम पे यहाँ अहमदाबाद का जिस सैटेलाइट एरिया जहाँ पे हमारा ये मेन कैंपस है, इसमें ये एक ही बिल्डिंग था. ये भारत का सबसे पहला अर्थ स्टेशन है, 1967 में स्थापित हुआ था. उस समय ये पूरा फॉरेस्ट एरिया था, जंगल विस्तार था. एंड इन दैट फॉरेस्ट एरिया ओनली दिस वन बिल्डिंग वाज एग्जिस्टिंग व्हेन साराभाई वाज हियर. So he was mentoring this particular activity, and this antenna we have right now. There is no use of this antenna, but still we have kept it as a heritage value. It is a symbol of our start of our space program. Jatul? Hello? Are you able to listen?
Hello. Yes, sir. We are able to listen you, but the PPT is not seen now. But video and we are able to listen you. Yeah, it has come now.
Yeah, so this, I was telling that this place is a heritage value. This was our first earth station of India, set up in this forest area at that time. Nowadays, if you come, you will not be able to recognize. It is such a developed and one of the most posh locality of Ahmedabad, this particular area satellite, where this particular earth station is located. And this was our main campus, and still it is our main campus. But below you, what you see, these are another two campus. These two buildings have come up, and then we have a very good exhibition. I'll tell you about that also. And then we have another unit called Development and Educational Communication Unit, which is like your schools. It gives us the feedback. It does the social research and other activities, film development, documentary development, animation, all these things, activity, and then they give us very important feedback. They will approach students, researchers, teachers, scientists, all these people who are the stakeholders in our space program, and try to get feedback about various programs, whether it is communication program, navigation program, and try to see that our programs are done correctly. And if there is a negative feedback, we try to correct based on this feedback, try to modify our program, do the course correction. So this is the importance of this particular activity in DECU. And then we have now these two new campuses in Bhopal, which is 7 kilometers away from our main campus here. And one will does the applications related to our navigation and other remote sensing activity, while this center is newly set up. Last 1.5 years it is working. It contains Asia's largest clean room, where we assemble the total satellite payload. So even China doesn't have such a big clean room. Clean room is the place where we assemble the various electronics and mechanical parts of a satellite payload. So at one go, we can have 6 major satellites can be integrated in this place. So so that this is the importance of this place, and there mostly this what we are going to talk today: satellite communication and navigation payload development. Hardware development happens at this place, and all the payloads are integrated at this particular yellow building which you are seeing. And as I said, it is Asia's largest clean room where we assemble this satellite payload. And below, one more antenna you are seeing. This is in Delhi. It is called Delhi Earth Station. And again, it has a heritage value like this 14-meter antenna, because our Honorable Prime Minister used to go to this place in 1970s and 80s. Indira Gandhi used to go to this place and address the whole country. Today, sitting at our place, we are able to do video conference, address, have video calls with one another. But that was not possible during 70s and 80s. So this time, when Prime Minister wanted to address the whole country, she used to go to this place at Delhi Earth Station. It is on Sardar Vallabhbhai Patel Marg. When you go from airport towards Prime Minister's house, in between this campus, again it is located in almost a forest area, and she used to go there and address the whole country from this place. So this again has its own heritage value for this particular. There are intermittent connection problems. So really worry. And this is one building you are seeing right now. We have written vendor complex. So this is that going to be the place where InSpace is starting its activity, although it will have its new campus adjacent to this. But immediately next 1-2 years, that Indian National Space Authorization and Promotion Center that is going to be inaugurated by Honorable Prime Minister next month, anytime. And this is the place where the startups and other activities will be, and private sector will start working. And it is also within our ISRO, this campus itself. And this is the new activity government wants to promote, where we want to encourage various researchers, startups, as well as private sector to take part in various space activities. So as I said, not only students, teachers, researchers, university, college students, everybody we want to involve in space activity. This is SAC, we do basically payload and applications. So as today we are going to talk on communication and navigation payload, optical and microwave remote sensing, which is the radar as well as camera systems, about which we are not going to talk today. So we'll talk about payloads and its application. So how communication, navigation, payload we develop and how its applications are going to be there. So that overview I'll give. And as you can see, Space Application Center is all type of people. We have mechanical engineers, electronics engineer, computer scientists, computer hardware people, then biological science, physical science, chemical science. Even if you are from science field, people are available here. Similarly, social scientists, I talked to you about social researchers in DACU. So we have a plethora of people who work in different fields. So there are different diverse field people from diverse field as well as diverse ideas. So it gives you a very natural environment for do uh, lot many debates, discussions, arguments, all these things. So that is the basic essence of the success of SAC and ISRO, is that we encourage discussions and debates. So any small fellow also can question a person like me, director also, that why things are this way. Any technical thing, any scientific thing, we always discuss, debate, question each other. So that should be the way of working even in your schools also. Students should be encouraged to ask questions to teachers. So it should be shot down that why you are asking. So see, even silly questions also we ask people, that we don't stop them from asking. So that is the essence of any success. So I will urge to teachers also that you should encourage your student, so that let there be their inquisitive mind be developed further. Let them satisfy their whatever inquisitiveness, whatever questions they have, because then that only will lead to better results, not only academically but from research and new ideas point of view. So that's why this Space Application Center is one of the unique center of among all ISRO center. You will see some of our center do only launch vehicle related activities. Some do only satellite building. Some do only scientific activity. While we are the center which we do all type of activity. As you can see from the type of people, number of people which we have, almost 2,050 people we have, plus almost 1,000 contract people are there. So total 3,000 people together, they work on not only hardware development, application, science, and various other activity, as you can see from the left hand side list. So that is the major uniqueness of my center, which is a multidisciplinary center, one of the unique center of ISRO. These are some of the achievements which we have done. Chandrayaan 2, all of you know, these pictures were very famous. You have seen it on TV, but what I'm trying to say is that today Chandrayaan 2 orbiter has completed 2 years in orbit, and it is giving us very good results, although we could not land. And that Chandrayaan 3 will be the lander mission, which is going to be there in due course. We will be having the Chandrayaan 3. Now, this is our basic Earth's atmosphere and beyond. So, what we define as space. So, then only will come to communication and navigation. So, as you can see, space will start from ground itself to 36,000 kilometers. That is generally the activity which we do. So, it doesn't mean that we do only satellite development or satellite launching. We start working from ground system itself. So, as I was showing you about ground segment activity related to our station, development of various balloons, as you can see here. So when we do the experiment, first we do it on ground in lab first, then take it to the field and have our station and all this type of activity. Then we go to air, that is airborne experiment, say balloon, aircraft, all these things. So many of this circuit we test in balloons, many of them in aircraft, and then finally we move to the spacecraft. So this is how the evolution takes place. And spacecraft also different types. It be low Earth orbit or mid Earth orbit or geosynchronous orbit. So there are different categories of orbits of satellite where we launch the satellite. So this is what is defining the space. So it is not only within the Earth atmosphere but beyond the Earth atmosphere also. And as I said, from 0 kilometers to 36,000 kilometers, we have all type of activity which we define as a space activity. This is our solar system. All of you know that. So, and it is part of your science study. So I don't have to tell you about that. But these are the principles on which we work basically. Why solar system I'm showing? Because we do many activities. So one is related to Earth. When we do communication, navigation, remote sensing, radars, cameras, that is related to our Earth planet. But apart from that, we do many interplanetary missions where we try to find out what is happening on Venus, and all of you know what is happening on Mars or Moon. So this anyway we are doing, but the many of the planets are very far off. So going to Mars itself will take 9 months. So this is still manageable. Similarly, Venus is nearby. So next mission of ISRO is going to be a Venus mission as far as interplanetary missions are concerned. Same way, we have future plan to explore Jupiter also. But going to Jupiter itself will take so many years. And you can think of going to Saturn, Uranus, Neptune, Pluto and all that. That is beyond our imagination. But still, sitting here, we do many of our other autonomous bodies like PRL, NARN and all, they do study related to all these planetary missions also. And all of you study that in your subject as a part of your science and other curriculum also. So basically all our space activity, whether it is communication, navigation, this is based on the principle given by these three gentlemen, Kepler's law of motion. Galileo gave us the first idea of telescope and other activity. Similarly, Newton's law of motions, all of you know that the three basic laws which govern, and these are part of your curriculum as a science also. But how the space is different is that these laws and physics and science part is okay. But apart from that, when we try to do something in space, what we face is the hostile environment. So gravitation of sun, planets, inter object effects, then satellite effect on planets, planets effect on satellites. So all these inter object effects, forces which act on that, radiation effects. So all these things we have to consider when we, and then vacuum and temperature. So these are the major things. So magnetic field, vacuum, radiation, temperature. So these effects we have to consider when we try to design any hardware for that. And then finally, once the satellite is put, its application. So we'll take the example of communication and navigation. Now, coming to the basic principle of communication navigation, as I said, there are different type of orbits, LEO, MEO, and GEO. So this defines once you are into the space. Till now, I was talking about ground system, balloon system, aircraft system, and I told you about the hostile environment in space. Now, when hostile environment will exist starting from LEO itself, whether it's LEO orbit, MEO orbit, or GEO orbit, all these orbit we face this hostile environment. So it is not that GEO environment will be more hostile. It is more or less environment is hostile in all these orbits. And what Arthur Clarke told us was that you can imagine that those days when there were no satellite, sitting at his home in his laboratory, he did some calculation and he found out and told us that with one satellite you can cover 1/3 of the Earth for communication. Similarly, with 3 satellites you can cover the whole Earth for communication. So now today it is a well-known fact, but those days when he gave this idea first time, you can imagine the imagination and the capability of his ideas, that how he gave this idea sitting at his laboratory, sitting at his place, in his home, in his laboratory, in his office, that theoretically 3 GEO satellite can, and that too at an orbit of 36,000. It is not that if I put it in LEO or MEO orbit, they will not be able to do communication. So you'll need, as you would have, all of you would have heard about now, Elon Musk's Starlink satellite series. So he wants to put some 8,000 to 10,000 satellites in LEO orbit. So if you want to put communication satellite in LEO orbit, you will need some 8 to 10,000 to cover the whole Earth, to provide internet through satellite. So this is the scale. But if you put satellite in the GEO orbit, 3 are good enough to do all the communication. So that is the difference when you put a satellite in LEO and when you put it in GEO. And MEO orbit is more famous for navigation. Why I have shown MEO is that at 20,000 kilometers or so, this MEO orbit, we have this navigation satellite. So these are the various satellite orbits. So I will not go into detail. So whether it is a equatorial orbit, geosynchronous. So when you say geostationary or geosynchronous, it is its movement, the rotation of the satellite is equal to the Earth rotation on its axis. So since both rotate at the same speed, they will appear to be stationary. So at night when you try to locate a satellite, even with a naked eye, many times you'll be able to see that satellite appears stationary. That's why you're able to locate. But LEO orbit, you'll not be able to see because they are always moving, as you can see here, from North Pole to South Pole or South Pole to North Pole in the polar orbit. This is called a polar orbit. Various satellite types are communication satellite, navigation satellite, radar satellite, whether it is optical camera systems or microwave radar system, weather or meteorological satellite, then space science telescope, observatory, which are used for astronomical and interplanetary satellite, which, as I mentioned about moon mission or Mars mission or any other Venus mission. Then we have various category of small and big satellites. So that also we try to make so that at a time, as you would have seen sometimes back, in 2018, we made a world record of launching 104 satellites. So I cannot put big satellite 104. So out of that 100 were small satellites. So these are the nano satellites or CubeSat or CanSat or PicoSat. So these are all the satellites. Many of the students in schools or in colleges, they build satellites which are of the category of these nano satellites, CubeSat, CanSat, PicoSat. And similarly, now we are going for this Gaganyaan mission. In future, after Gaganyaan, when we succeed, we have planned to put a small space station. All of you have heard about International Space Station ISS, which is a joint effort of some 32 countries. India is not part of that ISS. So many of you may be aware of that. So India wants to make its own space station, which will be a mini space station. It won't be that big as that. But why India is not part in the ISS? Because we have that time we were still emerging and we have not provided any circuitry or any application or any experiment for that mission. Because if you want to be part of that, then you have to give some money as well as carry out some of the activity related to that space station. So since India had its own program, we have not emerged. This is a particular look of the satellite, how satellite look like. So it is also like a normal, like your house. So it has walls. So north panel, we call it panel, north panel, south panel, east panel, west panel. Then there are solar panels, like in your house you have electricity generation, electricity comes from outside. Same way we generate from solar, or the sun will provide the energy which will be converted into the electrical energy. So solar panels are there. Then there is a battery backup is there, so that when solar panel is getting charged, we utilize the power from the battery. So like that, there are different. These are mostly the mechanical component or the hardware component of, because we want to maintain the orbit of the satellite. So you need thruster because we need to correct the orbit of the satellite. So like that, we need fuel for this correction, because when you want to fire the thruster, it will take away some fuel, like your scooter or your car. It will consume some fuel for this orbit correction. So these are all the part of the necessary constituents of any satellite, and this is the electronic constituents of the satellite, where solar array, where which does the conversion, then various various sensors are there to maintain the orbit of the satellite. We and try to have communication with the Earth. So these are all the major other activity which our satellite center at Bangalore does this activity, and the heart or the brain of the satellite is the payload. So that payload work, as I mentioned, is done in Space Application Center Ahmedabad, which is the various application of communication and navigation. Now, when communication, how it started. So in 1975, when Professor Yashpal was our director, all of you know about Professor Yashpal because he used to come on TV also with the various programs, and he used to explain in very simple terms various science queries or science questions of all of you, students especially. So those times, since India wanted to build its own satellite, and that too communication and navigation satellite, so we started with this activity, as Sarabhai said, that we should do first application. So what we did, we hired an American satellite, ATS-6, and did this satellite instructional TV experiment, site experiment in 1975. Now you can imagine 2,400 rural villages. Many of you may be sitting in villages or towns, small towns. So such 2,400 villages and towns, we gave these TVs, and this TV program was transmitted from this ATS-6 satellite. And you can imagine at simultaneously all this. Nowadays, all of you are very much familiar with TV, and the TV is not a novelty. All of you know TV will always work with DTH and all these things. And earlier our national TV, Doordarshan used to be there, where we had single program. But the TV is considered to be a very common thing. But those days in 75, and you can imagine those days electricity was also not there, and especially in villages. That time we did this experiment. So we provided electricity and then connected all of them with this ATS-6 satellite by beaming programs through this. So we first time we conducted how communication happens. It is a broadcast communication from satellite to your TV. So that is also one sort of communication. So this was our first, India's first exercise in communication. This was this TV experiment. And that was followed by what we call satellite telecommunication experiment project in 77 to 79. So these 2 years we did this, since India wanted to build its own national satellite system. We call it INSAT, Indian National Satellite System. So we carried out how to use this satellite, because building satellite and then starting how to use that is not a good way of doing any system or new thing. So what we did, we again hired this American satellite and tried to do the communication experiment during these 2 years. So we did this disaster warning system. So we gave out warning system by transmitting audio, video, all these signals, then radio networking, transmitting radio programs, then transportable terminal we took to different places and tried to communicate with satellite. So these were our first attempt at doing communication experiment. And this first, we wanted to build our own satellite, but at the first go, India didn't have that infrastructure. So what we did was, after doing this experiment, we gave order for contract for building satellite to an American company called Ford Aerospace. So in 1977-79, after doing this experiment, we gave contract to an American company called Ford Aerospace. Today that company doesn't exist, but this was the first time India gave its contract to this company, and they built 4 satellites for us. Out of that, 2 worked and 2 didn't work. So this was our, and what we did, we sent our engineers that time in 1979-80 time frame. We sent many of our engineers to America those days in 1970s and 80s, late 70s and early 80s. So they went to USA, they took part in the design of this INSAT system, and they took part in the testing part also. Of course, the fabrication assembly, because we didn't have facility in India, so that was all done in USA. And but design and testing part, our people learned that, and then when they came back, then India started its own program. So INSAT 1 series was built by America, that private company of America, Ford Aerospace, and after that we did everything now in-house. Everything happens in India only. So these were the various applications of communication. So where we do the TV broadcast, then all of you see in TV this picture, meteorological cloud cover and all these pictures as a part of your TV news, which gives you the information about the weather. So, and any disaster, if cyclone is coming, so that information also comes. So that also comes from this communication satellite in a geo orbit. And similarly nowadays, we all of you telephone from one place to another, from India to USA or from India to Russia or any other place. So that all communication happen through satellite. Of course, many communication also happens through fiber optic network, where undersea cables are also laid between 2 continents. But many of the communication still happens through satellite also. So that is another major use of satellite for doing voice, data, audio, video, all type of communication, and through your telephones as well as through the very small aperture VSAT terminals. And same way we have mobile satellite service. Now everybody is obsessed with smartphones, but smartphones communication happen through towers. All of you have seen these mobile towers are there all across the city. But when disaster happens, or when the towers are not working, or when network coverage is not there, what will happen then? So in the rural areas, the remote areas, or wherever the network coverage is not there, that time satellites will come into the help, and you can communicate through same phone through the satellite. So that is called mobile satellite services. So that also we are providing. And then another major activity is, as I told, about disaster warning and emergency communication, because any disaster happens, flood or earthquake or any other such disaster, first thing casualty is that your communication phones become dead. There will be no communication through your normal communication channel. So that time only satellite will work. So that is another use of satellite communication. And then you have telemedicine and tele-education. So like your school education programs are beamed through satellite. So there are various TV channels are there which will give out the various as per your syllabus of 10th, 12th, or even college syllabus, engineering, medical. So all these tele-education programs are run by various institute through satellites. And same way telemedicine. So when you want to consult a doctor from a remote area, say our soldiers are there at the border area, they want to consult a eminent doctor or a consultant at a different place who is sitting. Mostly these doctors are in city only, so in big hospitals. So you can have communication through this telehealth program, telemedicine program. Through using satellite, we can communicate. As you can see the pictures here, we can have our VSAT terminals or the mobile terminals are installed at the hospitals and the remote areas, and we can do the communication to cells. So this was our first communication total history of ISRO's communication program. As I was mentioning, INSAT-1 series followed by INSAT-2 series. So INSAT-1 series was done by Ford Aerospace, American company, and out of INSAT-1A, B, C, D. So INSAT-1A failed after launch. Similarly, INSAT-1C, there was a power supply failure was there. So these two satellites didn't work. Only two satellites worked, 1B and 1D. Similarly, INSAT-2 was completely built by us. So whatever our engineers learned after going to America during INSAT-1 time frame, they utilize it to develop the INSAT-2 satellite series. And from then onward, all our satellites are built indigenously in India itself. Of course, for components, electronic circuit, many times we are dependent on European as well as Americans for getting the components, because we don't have in India, the component industry is not there. It's not developed. We have missed out the microelectronics revolution. But all other activities are done here. We assemble the whole satellite, we test it, it passed through various testing methodologies, because we have to create high temperatures, low temperatures, vacuum conditions, radiation effects. So all these things we do testing and then make it suitable and then integrate it with the satellite. The payload, as I mentioned, is the heart of the or the brain of the satellite. And then the satellite body, which I showed you the different elements of the satellite body, they are integrated into our Bangalore center, and then everything together is taken to Sriharikota, which is our launch center from where we launch the satellite. And the launcher also comes there. We integrate the satellite into the launcher, and then the whole assembly is integrated, put at the launch pad, as you can see on your TV at the time of launch. So in the rocket, inside the rocket, we put a satellite. Inside the satellite, we put the payload or the heart of that, which is developed at SAC. And then everything is launched. And then after the launching, when the satellite gets separated from the launch vehicle and it puts into the proper orbit, after that only we are able to do communication or navigation or this type of application. So this is in totality the sequence of events. So today we have, as I mentioned, our first experiment, indigenous experiment was this Apple program. ATS-6 was hired from America, where we did the experiment for application. After that, we developed our own Ariane passenger payload experiment, Apple. That was our first geo satellite. It was just an experimental mission, having some science payload so that we can learn the satellite constituent related, structure related, electronics related, various parts. And then after that, INSAT-1 series, as I mentioned, was subcontracted to an American company, followed by INSAT-2, 3, 4. And now, since we build our own satellite and we launch it from our own place itself, from Sriharikota, we call all now our communication satellite as GSAT satellites, geosynchronous or geostationary satellite series. So we call it GSAT 1, 2, 3, 4, like that we give different names. So today we have GSAT 7, GSAT 24 is going to be launched on 22nd June. So please see it very carefully on your TV on 22nd June, early morning. It will be launched from French Guiana because it is a very heavy satellite. So our launcher don't have that capability. So although we have built it in India, the satellite is now shipped to France. From France, it went to French Guiana, which is an island. And from that island, there will be Arianespace 6 rocket will be there, which will launch this satellite on June 22 this year. So it will provide you some 24 DTH channels, not 24, 32 DTH channels will be provided for our country, and Tata Sky is the main customer for that particular satellite. So this satellite is going to be launched on 22nd June this year. So all of you, and as I mentioned, it is putting satellite is one part of the story, but you should have on ground various terminals to use the satellite. Because, and in fact, we have in Antarctica also a communication earth station. Like I showed you that earth station in Ahmedabad with that 14-meter antenna. Similarly, a Delhi earth station. Like that, we have earth station all across our country at different places in Bangalore, in Ranchi, in Calcutta, in Delhi, in various parts of the country where we call it hub or gateway or earth station. And same way we have at Antarctica also a communication station is there, because whenever our scientists go to Antarctica, so there are two earth stations there, Maitri and Bharati. Two stations are there in Antarctica, and in Antarctica you can go only from December to April. This period only you can go. Otherwise, it is almost unreachable there. So much cold is there, so much snow is there, so much ice is there. So during this period, when we go there, that time we try to maintain this particular earth station, which is there at the Bharati earth station is for communication. There is another station at Maitri. So these two are our Indian station in Antarctica. Only 7-8 countries have their stations in Antarctica. India is one of them. So like that, what I am trying to convey is that you need various ground element or ground segment electronics also to use the satellite for communication. And this was our gift to our neighboring countries. So GSAT 9, our Honorable Prime Minister said that we should support our neighboring countries like Bangladesh, Sri Lanka, Bhutan, Maldives, all this. Initially, Pakistan was also part of this, but then they created a lot of problems. So then finally, all of us decided that if they are not interested, let them be out of this. So initially, it was called SARC satellite because of the SARC group is there, where Pakistan is also member. But since Pakistan opted out, now we call it South Asia satellite, GSAT 9. So it is still working. We have provided two transponders to each of our neighboring countries. So all our 7, so after the launch in 2017, the satellite will work for almost 12 to 15 years. So Prime Minister immediately organized a video conference with the neighboring countries' heads, and they were told about this satellite, and we are offering free of cost these transponders, and we are also setting up earth station in these countries so that these people can use Bangladesh, Afghanistan, Bhutan, Maldives, Nepal, and Sri Lanka. So these are our neighboring countries. They are our friends, and we support them with this satellite and by helping them to do communication. And same way, this was our now communication. The trend is toward high throughput satellite. All of you know you want large bandwidth, large data rate in your internet also. So this is the first GSAT 19s. This was the high through. Now the trend is earlier the satellite was 36 megahertz bandwidth satellite, where you can accommodate very limited number of TV channels, because each TV channel will occupy 3 to 5 megahertz of bandwidth. So in 36 megahertz you can accommodate only 12 to 15 channels. But today when I have this 200 megahertz high throughput satellite, in each channel I can accommodate almost 50 channels. So like that I have 100 or 30 to 50 transponder. So you can imagine why, because in your TV now you have thousands of channels. That is possible because we have these high throughput satellites. So like this, there will be a beam structure that will cover our whole country. So this was our first satellite, which we launched in 2019. This was called GSAT 19. And then today we have GSAT 11. It is one of the biggest satellite India has ever built, GSAT 11, high throughput satellite. So for this it contains some 16 beams are there in 2 polarizations. So total 32 Ku band user beams are there, and we can provide 15 gigabits per second of data rate. And for that we have set up 4 earth stations. Each place there will be 2 earth stations, because when the rain comes, we switch from one earth station to another earth station. So this, as I mentioned, so making satellite is only one part of the story. You need such an elaborate ground network also with earth station. So this was that GSAT 11 satellite, which is a very big satellite. As you can see, it is weighing almost 6,000 kg. So it is on the, we call it a bus, I6K bus, because of the weight of 6,000 kg. And in India, our launch vehicle don't have to launch such a big or a heavy satellite. So we have gone to Arianespace, again to French Guiana. Arianespace was launched by that Ariane 5 rocket in 2019 that time. And this satellite is one of our major satellites, and it is one of the biggest satellites ever built by India. And as I was mentioning, after this big satellite, we have what we call mobile satellite. So, like you have this mobile network on Earth, on the ground, with the various mobile towers being set up, we have now mobile towers set up in the sky, that is in space. So, this GSAT-6 is our mobile satellite in space, and these are the terminals which we have developed. So this is like your smartphone. Of course, it is slightly bigger than your smartphone, but it works like your smartphone, where you can communicate whenever you are moving, and whenever you don't have your mobile network, you can switch over to the satellite network and you can communicate through this GSAT-6 satellite. So right now it is being used only for strategic purpose and government activity. It is not available for civilian user or common user like we people, or for Jio or Reliance or all Vodafone or other Airtel, or we are not providing these services for these commercial service providers, because right now the usage is bandwidth is limited, so restriction is there. So we are using it only for strategic users. So and these are some of the earth station. Till now, as I mentioned, we have to build big earth station for that, and for building the earth station, right now we are importing all the earth stations. So each earth station for a satellite will cost you around 250. For 4 earth station will cost you 250 crore. Means each earth station is roughly around 70 crores or so, 60 to 70 crore. So right now we are importing this technology from USA or Canada. So now what we have done is at our center we have started developing all these antenna, then other electronics related to RF technology, microwave technology, transmitter, receivers, everything. So because we have that capability, but in integrated way, our station we have not developed. So this activity also we have started, and shortly we will be self-sufficient, Atmanirbhar. So the government wants that we should be Atmanirbhar in all the activities which we do. So with that idea, now in future we will have our own earth station, so we'll save a lot of foreign exchange by doing it in India itself. Now coming to the other part of navigation. So till now we were talking about communication. Now what is navigation? All of you know that GPS and all, so I don't have to tell, but normally when earlier we used to travel at an unknown place, say you come to Ahmedabad, you don't know about Ahmedabad, or where you want to come to my place at Space Application Center, or you want to visit this Gandhinagar Institute, Dhirubhai Ambani Institute of Information Technology. So where is that located? So what we'll do, even if we are traveling in car or if we are traveling in bus or train or whichever way, we try to locate somebody, a panwala say, and ask him, where is this place? Say, I have reached Gandhinagar and I want to find DICT. Or I have reached Ahmedabad and Ahmedabad I want to find out where is Space Application Center, ISRO. Where is the satellite area? So what you'll do, you'll ask somebody. Generally we ask the shopkeepers or for panwalas or any other thing. So that was the traditional way of finding your way. But today, nobody asks anybody. You are sitting in your car, you switch on that GPS and try to locate, and you will be navigated through that Google map and all that. So that is how the technology has changed, and this revolution has taken place because of the navigation technology. So there are many navigation satellites moving in space. All these satellites provide the information with the help of which Google is able to provide you the route or the navigation aid to go to a unknown place even without asking anybody. So you can find out the location, what is the latitude, longitude of a place where you want to go, whether it is Space Application Center or DICT Institute in Gandhinagar or any other place in any other town or village also. So to such extent the navigation technology is being used. Now India generally we claim that we are the leaders in navigation. Why? Because we say, I mean, our Sanskrit, we already have the now, this word is there. Navagati was used many times in our ancient Sanskrit scripture. So Sindh River navigation was born. That is all claims, but there is no authenticity of these claims. We claim that. Many other countries also claim that we are the pioneers of navigation, but India also claimed that. And what is the principle of navigation? Is that we want to find out PVT. What is PVT? That is position, velocity, and time. So when you want to do navigation, you want these three information. It is called position, velocity, and time, or position, navigation, and time. And like what Arthur Clarke told, 3 satellites can cover whole Earth for communication. Same way here also for navigation also 3 satellites can cover the whole Earth. If you have 3 satellite navigation satellite, I can do navigation all across the world. Sitting here, I can find out. Today I have come from Amsterdam and Bonn, so I can find out what is the place where my institute was located in Bonn or Amsterdam. Sitting here, I can find out with these 3 navigation satellites. Fourth one is needed. You are seeing 4 in the picture because fourth one is needed to make it more accurate, or we call it geometric dilution of precision. So it will, since we want timing information also, generally 4th satellite is also required. So in general, 3 or 4 satellite will be able to give you the total navigation information. And India has its own navigation. We have this Gagan, which we developed by 2015. And by 2016, we have this Navic or navigation with Indian constellation or our own GPS that was in the orbit. We have still not declared it operational, although 5 years have gone by. Reason I will tell you. So this is how navigation happens. You know about communication. Sitting at one place, you can switch on your phone, communicate with your friend or your family members sitting in USA. So that is through the communication waves or the microwaves through the satellite, which will go from your place to the satellite to that American place. So that was communication. But navigation, how it happens, that satellite, with respect to satellite, I locate where I am sitting right now. One satellite. Then I will locate with respect to second satellite. Then with respect to third. Because any location when you want to find out, you want what we call, when you solve any equation of your coordinate geometry, it is X, Y, Z information we want. And the fourth one I want is timing also. So that's why this 4 satellite together will give me, when you have 4 variables, X, Y, Z, and T, you need 4 equations to be solved. So for 4 equations, you need 4 measurements. So that is the principle behind any navigation. So you need 4 measurements. So this 4 measurement will be taken up to do solve this 4 equation. And then once you get this 4 measurement, solve the 4 equation, you get X, Y, Z, and T. That is X, Y, Z will give you my latitude, longitude information where I am located, and time will give you the timing at that particular place. So this is the basic principle. This was the Gagan first. India started with this program, what is called Gagan. The Gagan is GPS aided geo augmented navigation. Why it was used? Because if you use GPS in aeroplanes, so the accuracy is not good enough. It is almost 10, 20, 30 meters. So for a pilot to land properly on an airstrip on its aeroplane, it will need 3 to 5 meters sort of accuracy, and especially vertical accuracy. So GPS generally don't provide you vertical accuracy. So to improve this accuracy, and the accuracy is one part of the story, it has to be what we call integrity of the information. It may give you a poor accuracy, but if it tells with authenticity or certainty that I will give you information with 10-meter accuracy, then also pilot will be able to steer the aircraft and land it on the airstrip properly. So all these things was not possible with only GPS. So there was a need of augmenting that. So additional payload were put in a geostationary satellite, so which will provide the correction factor, because atmosphere will distort the signal. So all these things were taken care of by this Gagan payload. And the other advantage of Gagan payload is that this receiver which I built for Gagan will work in USA also, it will work in Russia also, it will work in Europe also, because the aeroplane will travel from any place to any place. Today I have come from Europe to India, so it has passed through many places in between. So the same circuit or the same receiver should work all the places. So that is the advantage of using this Gagan or a SBAS receiver. It is called a satellite based augmentation system, SBAS. So Gagan is the Indian name of these. Similarly, American call it VAS system. So you need only one type of receiver, because aircraft cannot have 10 type of receivers for each system. So same receiver will work in USA with the VAS satellite system. In Europe, it will work with IGNOS satellite system. In India, it will work with Gagan satellite system. In Japan, it will work with MSAS, or Australia, it will work with MSAS satellite system. So that is the advantage of using Gagan. So now, even in bad weather conditions, pilot will be able to use this receiver information. It will give information about vertical height, horizontal distance, and all these things. So pilot will be able to land even during foggy conditions, bad weather conditions. That is the advantage of Gagan. We'll not go into much detail, but we'll concentrate more on navigation, which is NAVIC. So these are our Indian NAVIC satellites. All of you know that GPS has 24 satellites plus 8 reserve satellites. So 32 satellites are there for GPS. While in India, we have put 7 satellites. So as you can see, there are totally 7 satellites. Why 7? And they need 24 or 32 because we are putting it in a geostationary orbit. So although by Arthur Clarke's principle and what I explained to you, you need only 3 or 4 satellites, but we have put 7 satellites because we want to do larger coverage, not only over India, but we want to cover 1500 kilometers in and around India. And we have this standard positioning service, which is available for all of you, for a common user or a commercial user, for a common man, while the restricted positioning service is only for our military service. And why we needed this navigation system? Because all of you will remember, some of you at least, that during Kargil war, we were using GPS everywhere. All our soldiers and all our weapon system, all our aircrafts, all our ships, all our armored carrier vehicle, tanks, weaponry, everything was dependent on GPS. And that time, what we faced the problem was GPS accuracy was degraded from 10 meters to almost 30, 50, 100 meters. So our weapons were not working properly. Similarly, either signals were not available many times. So if we fire a missile, instead of landing in Pakistan, it will land in India itself. So all these type of problems we were facing. So after that, government set up a committee, and we decided that India should have its own system of navigation. So with that idea, this whole concept was built. And from 1999 onwards, when government gave go ahead for the development, so from 2000 onwards, we started working on various technologies. See, overnight we cannot develop a navigation satellite. So first we have to see the various requirements of navigation, various electronic circuitry needed, various hardware elements needed, various mechanical activities needed, various ground station elements needed for that. Because as I said, any navigation is not only satellite, but there is a lot of ground station to be built. So all these things we worked on, and by 2016, we were ready with everything. We launched all our 7 satellites. We had all the ground segment in place, and we are ready to provide all these 2 services. But still, we have not declared it operational, because when you declare anything operational, it is then compulsory for government or the agency which is providing service that it should be provided on a 24/7 and an assured basis. Because anything GPS is today, if you see, it is an assured service provided by USA. So 24/7 it has to be provided. So same way, when we'll declare it operational, when we are sure that we are ready with all the spares and other things to provide operational service. But today government and our defense forces and many other commercial users, they use these NAVIC services. And the plan is that we want to replace GPS with our NAVIC system. And wherever we cannot replace, because this is our regional system, it works only in India. So wherever for some activity we will not be able to replace GPS, so there we will augment it with the NAVIC system. So that is the idea with which government and ISRO is working. And here is the comparison of various other systems. So this GPS is from USA, GLONASS is the Russian system, Galileo is from Europe. Europe together, 28 countries of Europe, they have combinedly put this Galileo system. Beidou is from China, and NAVIC is from India. And there is a Japanese system also, QZSS, but it is more augmentation of GPS. They have put additional 3 satellites which will work together with GPS. So I have not shown it here. But these are the 6 countries who have their own navigation system. So we should be proud enough that we have our own navigation system. But the difference is that our frequency bands are different from rest all others. So we took more time to develop, because we have to develop all the things from starting from scratch. So that was the difference why we took so much time. And still we are trying to put the user segment, because the receiver chips are not available. We have to build our own chips. While the GPS chip will work for GLONASS also, Galileo also, Beidou also, but it will not work for our NAVIC system. Because by changing the software or the program, I cannot use the GPS chip, while all other people can use that way. So we have to develop everything from our own system from scratch. So that was the reason why we took so much time, and still we are taking time to make it operational. So if you compare, we are comparable in accuracy in all other respect, except for this frequency band and the height at which we are putting the satellite. Rest all satellites are in the MEO orbit at 20,000 kilometer, while our satellites are in 36,000 kilometers. So these are the logo of various things. Our logo is also very attractive logo compared to other. Is almost similar, and we are almost equivalent to all the other service providers. So as I mentioned, we are not only covering the whole Indian region, but we are covering 1,500 kilometers in and around India. So that is our coverage area. This is the latitude, longitude over which we cover, and it will provide all weather 24/7 operational. Once we declare it operational, and it will provide for our defense forces also, strategic sector, also the service will be provided. So these are some of the pictures of when we made these satellites. And this is a continuous process, because navigation satellite is one such business that regularly we have to, one satellite which goes bad, we have to replace it with new satellite. So old satellite, we bring it down so that it burns out in the atmosphere, and we replace it with a new satellite. And we have to always keep spare in the orbit also. So these are the satellite we are building. So this is how the satellite was tested. This is how it was integrated in the rocket launcher. This was the antenna was tested in the EMI-EMC chamber. And this is how the total satellite was tested on a vibration chamber. Because when you launch the satellite, a lot of vibration and shock it will encounter due to the launch vehicle. So these are all the testing which every satellite passes through. So navigation satellite is not an exception. And as I was mentioning, apart from having the satellites, we also need to put up all these earth station, ground station, timing station, data communication network, range and integrity monitoring station. At some 16 to 20 places, we have to put this IIRS station. So they regularly do monitor these 7 satellites and give us information which are utilized to do correction. Because any navigation, we have to regularly do correction factors are to be provided. So these are the navigation receivers which ISRO has built. So as you see here, initially we built very big receivers because we were developing it for the first time, and today we have receiver on a single chip, and tomorrow it will be part of your mobile also. So it will be a very small chip. It will be part of your watch, your clock, your mobile. So that is how the technology is moving. So you can see here, this is the size of a brick, and today we have size of a small chip. And from the small chip again, it will go to as a part of your mobile or a watch. So this is how these various chips are built in India as well as outside. And these are the accuracies we achieved. So almost 3-meter accuracies is consistently achieved, whether in North India, South India, East India, West India, Northeast, everywhere. And this is that small receiver, which I was showing this chip, which we have built. And what you see, the building parts of that. And some of you, if you are aware, some of the students who are right now studying in school, when they enter the college and study engineering. So what we study in engineering, there is a 4-year subject. Okay, 4 year you have to study engineering. So electronics and communication engineering. So in 4 year, whatever subject we learn, so almost every semester we learn 5 subjects. So every year we learn 10 subjects. So in 4 years we learn almost 40 subjects. So whatever we learn in that 40 subjects, everything is utilized to develop this one small chip. That is the beauty of this, or the power of this chip. And it has to be low power, very miniaturized and small one, so that it goes inside your mobile or inside your watch also. So, and whatever we study in 40 subjects as a part in 4 years in our engineering, electronics and communication, everything we have to use it, that knowledge, to develop different circuitry, and these all are integrated as a single chip or a single circuitry finally into your mobile. So this is how the technology miniaturization, and the power has to be minimum. It should not consume more than 10 milliwatt or 20 milliwatt of power. Otherwise your mobile will drain out. Then nobody will use that sort of circuit. So this is how you will feel that this Ola or Uber, when you hire, it shows your navigation path and you are able to reach your destination very fast with the help of the Google Maps and Google Navigation Aid. But behind that, this is the technology involved. and these are some of the, and it will also need an antenna, because first you have to capture the signal from satellite. So these are the various antenna which are built. So many antenna will become part of the chip itself. So the top of the chip will work like an antenna. So this is how we have developed, ISRO has developed various antennas, various chips, and they are being used to say, like now you see these blocks at various places, at railway station, at airport and other places. So this timing we have synchronized with the navigation satellite. So all our timing now, it is universal timing also being synchronized. We call it Indian Standard Time or Universal Time UTC time. Everything we will be synchronized with our navigation satellite, which provide the timing. It is synchronized with respect to that. So and our power station, everything. So and today, why navigation is important? Because almost 95% of activity which you do, you will not know that. It is hidden from you, inadvertently or inadvertently. Whatever, almost 95% of activity which we do in our daily life, they are governed by GPS as on today. So you can imagine the power or the powerfulness of this particular technology called navigation. So whether it is location-based services, location-based service means you go to a new place, try to find out, locate a shopping mall or a railway station or airport or a movie hall or a multiplex or all these things, and road transportation that I mentioned about Ola, Uber, all that you want to hire that. So how to navigate on road, which road to take so that you can reach in the shortest time. If you want to go to an unknown place, what route you should take. So whether it is aircraft or spacecraft or your motor vehicle or your mobile or anything. So everything is governed by the route shown by GPS. So there are all these activity, and even in science research also we utilize this GPS signal. So same way we want to use the NAVIC signal. So almost all the activity you can see here, almost anything you can imagine, everywhere GPS is being used. So same way now NAVIC will be part of all these activities in India. In China, if you go, everything is governed by Beidou only. Similarly, if you go in Russia, because their government has made a rule or a regulation that if you are in China or in Russia, you have to use their own system. So in Russia, you have to use GLONASS only. In China, you have to use Beidou only in your mobile also. You cannot use GPS. So something similar, we are urging our government that we should come out with a rule or regulation that all our mobiles, all our activities should be governed by NAVIC only. And that is going to become a reality in near future. So these are some of the activity which we have already demonstrated. So your railway tracking, so your Shatabdi or Rajdhani train, when you travel, they are being regularly tracked by our NAVIC signal. So NAVIC, the 7 satellite provide the location of the train which is moving, and our mobile satellite, through that it is transmitted, it goes to New Delhi, Chanakyapuri, there is a ground station there. It will receive the signal from all the trains which are moving in our country. So almost 2,800 trains we have already installed this, and now another 6,000 train we are going to install in near future. Same way in all the boats which are in the various oceans, they are moving around, and there are 4 lakh boats daily. Out of that, 2 lakh will be daily moving around in various sea, whether it is Indian Ocean or Bay of Bengal or Arabian Sea. So they are being regularly tracked. The government's plan is, because after the Bombay attack happened, where a Pakistani boat entered into Bombay and nobody noticed it. So now all our Indian boats will have this terminal. So we will be able to identify Indian boats. So whenever any international boat or the foreign boat will enter our sea surface, they will be found out that there is some unidentified boat is there, and the Navy will be tracking it. So this is for coastal surveillance. So like that, for aircraft tracking also, we'll be doing this. Similarly, somebody wrote to Prime Minister that many of our soldiers are doing patrolling in this Siachen Glacier. Many of you would have heard the name of Siachen Glacier, where we share the border with Pakistan. So we protect this Siachen Glacier, which is under India's control. So every 3 months or 6 months, we send a battalion of soldiers. They stay there because there is temperature of minus 55 to minus 60 degrees centigrade. So you cannot survive more than 3 to 6 months there. You have to come back again. So new battalion goes. So when they are there, many times snowstorm come, avalanche happens, and many times our soldiers die, and we are not able to even locate their bodies also, where they are buried. So somebody wrote to Honorable Prime Minister that why not you use your communication and navigation technology to at least locate their bodies so that we can bring them back. Otherwise, they got buried forever in that Siachen glacier itself, and their relatives are not able to see their body even. So that's why now we are developing a small receiver which they can wear it, because they cannot carry a big receiver because they have to carry ration and other things. So, and there is no provision of charging on the Siachen glacier. You cannot charge your battery. So the receiver has to operate with a battery so that it lasts for 3 to 6 months when the soldier is there. So when they move on the Siachen glacier, regularly their movement will be tracked using that receiver. Sitting in Srinagar or in New Delhi, we will be regularly seeing where they are moving in the Siachen glacier using our navigation and this communication mobile satellite. So this is one application which will be very useful for our soldiers who work for the sake of our country, and they even lose their life for our country. So at least this much we can do with this our technology. And similarly, when we want to land in hilly areas, especially for our defense forces, they want to land near the Chinese border or Pakistan border, in northeast, in Kashmir, all these places, it is very difficult for aeroplane to land. So that time we have developed this new technology called pseudo-light technology. So you set up a temporary airport there by setting up these 10 receivers on ground. So they will work like a navigation system for the aircraft which is going to land there. So this is how technology is being utilized for different applications. This is how normal vehicle tracking, these all of you know that, so I don't have to tell you. Ola and Uber regularly use this. So you can see on the screen using GPS, but now we want to use, instead of GPS, Navic is being utilized. So all these experiments we have already done. So you can see on the map or the screen the movement of the vehicle as you move around in a city, or you go from one city to another city. You can track the movement of this particular vehicle. I think that I can show you one particular vehicle. Will they be able to see? This is how in our campus vehicle is moving. So the track of that vehicle, you are seeing that green, this thing. This is my SAC ISRO campus. Inside that we are moving a vehicle and tracking it with our Navic signal. So this information will be available from Navic, and it can be transmitted through internet also or through mobile satellite. Same way when we send our satellite payload from Ahmedabad to Bangalore, so it goes in a truck and it goes in a very secure, with high security. So we regularly sitting at Ahmedabad in my office, I will track the movement of the payload, because it is a very precious payload costing hundreds or thousands of crores of rupees, and it is the truck which is carrying that payload or the circuit or our satellite payload. It moves at a very slow speed, 20 to 40 kilometers is the limit. So it has to go from Ahmedabad to Bangalore. So regularly, like your Ola, Uber, we will track using our satellite its information, where it has reached, how it is. So it takes around 3 to 4 days to reach, and with heavy security it goes. So all the, but sitting at my place, I will try to see that everything is fine. So these are some of the applications where navigation. Similarly, aircraft tracking. So aircraft, when it is moving in the sky, because you would have seen that many times. Recently, our chief of staff, Mr. Bipin Rawat, his helicopter crashed. So like that, to track those helicopters or aircraft, even after the crash also, we are not able to locate them. So if we continuously track the movement using our navigation and mobile satellite. So this is how navigation and communication technology together we can utilize to track the movement of all the aircrafts. Right now, only air traffic control, when you move from one country to another, that ATC, when it is near the ATC tower only, they are able to track. and otherwise they are dependent on radar systems. So instead of that, now regularly if we use this communication and navigation system, so aircraft will carry that receiver, which will be continuously tracked through our navigation satellite, because satellites are in space, so they will be able to give the coordinates of any moving target, which is transmitted through our communication satellite, and at any hub we will receive that, and we can regularly track the movement. So movement of important politicians or important ministers, prime minister, all these things we can track if their vehicle is mounted with this. This could be in aircraft also, it could be on ground also, it could be in ship also. So the technology remains same, both navigation, communication together. So this is how, when say like in Naxalite area where our CRPF patrolling is happening, the soldiers, there will be one battalion sitting outside the forest and another goes inside the forest to catch the Naxalite. So during that movement, many times Naxal will attack the CRPF patrol. So that time the people who are sitting outside the forest, they have to rush immediately with the reinforcement. So all this information will be possible only if they are regularly tracked. So all these things also we are providing. So like this in a forest area, again through our satellite, so immediately there will be a node in the control center also, and just outside the forest area also. So both places they will regularly track the people who have gone inside the forest, and if they are in trouble, we automatically come to know about that, if they got stalled or they get attacked, and then we immediately rush the people who are sitting just outside the forest, they will go inside. So like this many pilot projects we have done. And we have all our launch pads as well as our tracking station for satellite and all we have synchronized with the NAVIC timing. So as I mentioned, position is one part of navigation, timing is another part of that. So timing is synchronized, Indian standard time is synchronized with NAVIC. Similarly, all our earth station, all their timing instances are synchronized with the NAVIC timing. Similarly, all our power station in India, right now they are all dependent on GPS timing. So that synchronization of power grid, because any time when war happens, the enemy will first attack your power supply. So your power grids are attacked and they will disturb the power supply, because if power supply is disturbed in a country, then you cannot do anything, because everything works on AC power only. So to protect that, we need to have now a NAVIC based synchronization, because all these power grids need synchronization because their frequency should not deviate from 50 hertz. Similarly, timing instance has to be maintained properly. So all these things right now synchronization happens through GPS signal. But now we have put at 5 different locations and try to compare GPS results with our NAVIC signal. So they are exactly matching. You see this curve. So now all our power grid synchronization slowly will be converted from GPS to NAVIC. So this is how India is changing. And now you can also synchronize your computer at your home or in your school or in your office with the NAVIC timing. So you can visit this site www.sac.gov.in and we will provide you the it is called NTP timing. With that you can synchronize your computer timing. So you are also synchronized, will be synchronized with the NAVIC timing, which is the national timing control. And finally the ultimate will be, it will be part of your mobile. So that is the aim of government, of ISRO, of everybody, that instead of GPS, of course you can use GPS, but along with that you should use NAVIC also, which is our own system, if you want to become Atmanirbhar and all that. So already many of the high-end mobiles, they already have NAVIC facility, but we are trying to see that it comes into your feature phone also, which is provided by Jio or anything. Now for all this we need, why this we are able to provide this high precision timing, because there is what we call an atomic clock in satellite. So all these 7 satellites contain an atomic clock. Right now the atomic clock which we are using is imported one, but we are developing our own Indian atomic clock also. It is called Indian Rubidium Atomic Standard. So this, with this we are able to provide you the nanosecond type of accuracy, because then only you will be have precise timing. And now we are working on the human space flight program also. So there also, this is the Gaganyaan program, just for your information. So it will carry a crew module like your room where the astronauts will be sitting, and this is a satellite part of that. So the satellite integrated with the astronaut room, they together it is called a composite. We call it a service plus crew module. So that is called orbital module. So this orbital module will go inside our launch vehicle, GSLV Mark III. And the original plan was that before our 75th anniversary of our independence, that is before 15th August 2022, we should be launching this Gaganyaan. But unfortunately, due to COVID and many other technology developments are still under progress. Because anything which is human, when we want to put everything, we have to now change all this circuitry. Already, although we have launch vehicle, we have to make it human rated launch vehicle. So that is not simple, because anything, say like for example in aircraft where human beings life are involved, if you want to change a small screw also, you have to do many certifications. You just like that, you cannot change anything in aircraft. So something similar in satellite also, we have to redesign everything to make it human rated. So this is how this program will be happening. So by this year, we will try to launch an unmanned Gaganyaan, and after that will be followed by a manned Gaganyaan within next 2 years or so. So these are the feature of Gaganyaan. It will be there for minimum 2 to 7 days. It will carry the astronaut. There will be minimum 1 to maximum 3 astronauts in space. They will move around the Earth orbit, and somebody will say Rakesh Sharma was already there. Then what is new in this? The new thing is that it is our own Gaganyaan, because Rakesh Sharma went in a Russian Soyuz spacecraft. While this will be our own Gaganyaan, which will be going from our own soil. It will be taken by our own launch vehicle. It will move around the Earth, and then it will be brought back onto our own soil. The Rakesh Sharma's spacecraft, it landed on the Russian soil. So unlike all these things, so everything will be indigenous, or we will become Atmanirbhar with this particular technology. So everything will be Indian, everything will be indigenous. So that is the novelty of this Gaganyaan program. And India will become the 4th country in the world which will have a human being in space once we succeed in doing this Gaganyaan. So this is how the whole thing is developed. And here again, this will be the orbit. It will move around the Earth for around 275 to 400 kilometer orbit, and will come back anywhere, either in Bay of Bengal or Arabian Sea. So 2-3 sites we are examining, and finally we'll select one of them. It could be near Andaman Nicobar, or it could be near Goa beach or the Veraval coast here. So any of these sites finally will be selected based on technical requirements. And the important part of communication and navigation in Gaganyaan is that, like a mother will not leave its child for even a second from her. So same way, when the astronauts are moving in space, even for few seconds also, will not leave them aside, because we will be always in 100% communication with the astronaut. So that is the major requirement of this Gaganyaan mission. So communication wise, it is a very challenging task for all of us, because right now with all available technology, we are able to provide only 40% communication. So if that 40% we have to increase to 100, means we have to coordinate with various space agencies of the world. Plus we are going to launch another 2, what we call data relay satellites, Indian data relay satellites. So they will provide communication with, they will be in geo orbit. So they are already stationary. So, and Gaganyaan will be moving. So wherever it moves, because Gaganyaan will be visible on Indian soil only for 4 orbits, 2 times in the morning and 2 times in the evening. So rest of the time it is moving in some other place, either over America or over Europe, over China, or all the other places. So we will try to maintain communication. So Gaganyaan astronaut will communicate through this satellite to our Earth station in Bangalore or in Ahmedabad. So this is how the whole system has been worked out. So again, communication is going to be a very important element of this Gaganyaan mission. Of course, other technologies are important. Putting man in space is not an easy task. But apart from that, providing 100% communication is going to be the most challenging from as far as the activity which space applications that the ISRO is doing. And after mission is launched, after that also it is not over. You will feel that once the astronaut comes back, everything is okay. No, it is not okay, because we have to, like in COVID time, we used to be in quarantine. Same way, a person who is gone in space, he needs to be quarantined first, because he is in space. He has experienced many other things, radiation, all these things. So, what is the impact on his body? What is his mental state? So, all these things we have to take care. So, first he will be quarantined for few days, and then he'll be rehabilitated. He has to come back in the society. So these are also part of that. So technology is one part, moving around the space is another part, finally bringing him to Earth back, and then doing quarantine rehabilitation so that he becomes again a natural part of our Earth system. So that these all are the elements when you do any human space flight. And today the communication has changed to what we call a quantum communication. So your PIN code which comes for any financial transaction, we are very much worried, because somebody should not be able to steal that, because otherwise your money is get lost. So we hear a lot about various cyber frauds and cyber crimes which are happening nowadays in banks and in any financial transaction. So the solution of that is again communication. It is called quantum communication. So we in Ahmedabad we tested this technology, and where it will be done through photons. So the advantage of this photon communication or quantum communication is that it will be very secure. Nobody will be able to hack it. Nobody will be able to steal it. If somebody tries to, when I'm doing communication, so I'm showing this example, we have communicated in free space from one place to another, 300 meters apart. So if somebody tries to eavesdrop or hack it, automatically this communication will stop. So this is how this is my SAC campus. In that we have tested this technology. And future is we will be putting satellite also. So these are new type of communication satellite which will be put. They are called satellite based quantum communication satellite, SBQC. So this is going to be the future when many of these students right now who are in school, they grow up, become engineers, they join ISRO. They will be working on this technology, for which right now we are doing some advanced R&D activity. But I will retire, and then afterward some of you will have to take up this activity, and this is going to be the future where everything will become very secure. So these are the activity we do: communication, navigation, science and technology, remote sensing. So many more activities. As today I have told you about only navigation, communication, but remote sensing is another area which is also very wide. Science and technology, interplanetary missions, all these things, Chandrayaan, Mangalyaan, various student activity we try to support with space clubs, space event. We can conduct mobile exhibitions. We come to your place and set up an exhibition. So now we have started, since COVID is over now, more or less. So all these things, you can utilize this opportunity and request us. We will try to see if we can come to your school and do this exhibition for 1 day, 2 days, 3 days, as per your convenience. So that will give you more information, and it will encourage more and more students. And this is our exhibition. Please do come whenever you visit Ahmedabad. You are welcome to visit this exhibition. It is in our main campus itself, and it is worth visiting it. You will get glimpse of all the activities which is not only ISRO does, but our Space Application Center does. These are some of the books related to ISRO, which if some of you who are interested can go through that. So we are doing lot many activities, and as Sarabhai said, for man and society, and for you students, teachers, all these things also we are working. So I hope, and all these things is possible because of our leaders, starting from Sarabhai, as most of them are well known to all of you. So I don't have to tell you about them, whether it is Satish Dhawan or UR Rao, or Kasturi Rangan, Madhvan Nair, Radhakrishnan, Kiran Kumar, Dr. Shivan, and now current chairman, Mr. Somnath. So these are and why ISRO is successful, because whatever is there available, we carry even the rocket part on a bicycle. People work with very high integrity, team spirit. Although there may be differences, people may be fighting with one another, but finally when we work for a project, people will work with that spirit that we have to succeed. We are working for the country, for the nation, for our people of India. So that will make us highly motivated. And there are that many ladies are there. Almost 30% of our manpower or the people, scientists which we have, they are all ladies. So we give very equal opportunities for ladies as well, for girls as well. So all in all, all these features or the characteristic help us to succeed. Thank you very much. I've taken much more time, but I hope it would have gained some information. Thank you.
Thank you very much. Sir, for a highly comprehensive lecture on ISRO's communication and navigation satellite arm and its applications. And आपको बहुत बहुत धन्यवाद सर, बहुत उत्साहवर्धक शब्दों के लिए जो आपने सारे स्टूडेंट्स के लिए जो एक्टिविटीज के बारे में जानकारी दी उसके लिए. Take one or two questions.
Yeah, no problem. You should have that page. बताइए.
So there is one question from Dr. Shivalik, microwave remote sensing.
Yeah, I could not get the question properly. बीच में break हो रहा है. Video.
The question is, what is the difference between optical and microwave remote?
Yes, very good question. Optical remote sensing means this, whatever cameras you see, where they depend on sunlight as a source of illumination. Because any camera, you don't carry any transmitter, isn't it? You just click the picture. Same way we carry a camera in satellite and the camera just click the picture. So we get picture of the earth. But when we do microwave remote sensing, we have to carry, it doesn't depend on sunlight for source of illumination. कैमरा में क्या होता है कि सनलाइट अगर प्रॉपर हो तो इमेज अच्छा आएगा, पिक्चर अच्छा आएगा. So that principle it works. While in microwave remote sensing, we carry a radar. So radar में क्या होता है, एक ट्रांसमीटर भी ले जाना पड़ता है. So we have to carry a transmitter also, which will transmit a signal. So that signal will go to the earth and some signal returns back, and that return signal we try to capture. और उससे इमेज फॉर्म करते हैं. The advantage is that one is you have to carry, that is the disadvantage, that you have to carry your own transmitter. Advantage is that it can work even in cloudy conditions, even if rains are there, even at night it will work. While unlike that, camera can work only during daytime and also during fixed time at between 10 to 1 o'clock or that sort of time, and there is bright sunlight is there, then only you get good picture. Otherwise also if you will not get good picture. You will get pictures, but they are not that good enough or focused enough. But unlike that, microwave radar or microwave remote sensing offers you these advantages. But इसके सामने disadvantage ये है कि बहुत costly है और इसका टेक्नोलॉजी कोई हमको खुद डेवलप करना पड़ेगा, कोई देता नहीं है. That is one part, and you have to carry the transmitter for that. But सामने advantages भी इतने ही है. So this is the basic difference.
Okay, sir. Next question from Dr. Vandana Bhadoria is, what is the difference between the data provided by lander and orbiting satellites?
Yeah, जो orbiting satellite है वो जैसे ये orbital landers generally planetary mission के लिए होता है. So जैसे कि मार्स या अभी तो हमने चंद्रयान तक ही हमने रेस्ट्रिक्ट रहे हैं. So चंद्रयान के आजू बाजू जो 100 किलोमीटर ऑर्बिट में हमारा ऑर्बिटर घूम रहा है. ऑर्बिटर इज लाइक अ सैटेलाइट. Like our satellite moves around Earth, similarly this satellite orbiter moves around the moon. तो मून की पिक्चर लेता रहता है, बहुत रडार की इमेज भी लेता है और कैमरा इमेज भी लेता है. So that is orbiter का function. It is more like a satellite which are moving around Earth. So similarly this is a satellite moving around moon, and it takes picture of the moon in different condition, different time, different parts, all these things. तो जबकि लैंडर जो होगा वो लैंडर वहाँ लैंड करेगा, फिजिकली वो मून की सरफेस पे घूमेगा वो, और जहां भी लैंड होगा उसके आजू बाजू लगभग 500 मीटर रेडियस में वो घूमता रहेगा 15 दिन के लिए, 14 दिन के लिए, क्योंकि उसकी लाइफ उतनी ही रखे. उसके बाद नाइट आ जाएगा वहां का, तो उसकी इलेक्ट्रॉनिक्स वर्क नहीं करेगी. तो वो 14 दिन तक वेरियस एक्सपेरिमेंट वी हैव प्लान, तो वो एक्सपेरिमेंट करेगा वहां से, और वो एक्सपेरिमेंट का जो भी प्लान किया है उसके मुताबिक कुछ रिजल्ट है वो टेलीमीटर करेगा ऑर्बिटर को, और वहां से वो हमारे ग्राउंड पे वापस आएंगे. तो वो इन सिटू एक्सपेरिमेंट जिसको बोलते हैं, जो आप लैब में खुद एक्सपेरिमेंट करते हो उस टाइप का इन सिटू एक्सपेरिमेंट लैंडर करेगा. उसमें भी कैमरा लगे होंगे तो वो सरफेस की इमेज और वो उतना ले पाएगा, बट लैंडर वहां बैठ के पूरे सालों के सालों काम नहीं करेगा। वो जैसा कि मैं बताया 14 दिन काम करके वहां जो उसकी उसकी सरफेस से सॉइल लेके उसका कुछ एक्सपेरिमेंट करना है, वो जो अगर हमने प्लान प्रॉपर्ली किया है तो उतना ही कर पाएगा। उसके बाद उसकी लाइफ या उसकी यूटिलिटी खत्म हो जाएगी। वाइल ऑर्बिटर हमने प्लान किया था लगभग 1 साल के लिए, बट अभी जो एस्टिमेट है क्योंकि उसका फ्यूल बहुत बचा हुआ है तो लगभग 6.5-7 साल तक वो ऑर्बिटर काम करेगा। तो 7 साल तक हमको चंद्र की इमेजेस हमको मिलती रहेगी, चंद्रमा की, मून की। बट लैंडर जैसा कि मैंने बताया, लैंड होने के बाद जो वो 14 दिन में जो भी एक्सपेरिमेंट करना है वो जहाँ लैंड होगा उसके आजू बाजू 500 मीटर घूम के उतना ही कर पाएगा। उतना करके वो रिजल्ट हमको टेलीमीटर कर देगा। कुछ हम रॉक वॉक ला तो नहीं पाएंगे क्योंकि हम वहाँ कोई गया तो है नहीं, जैसा कि अर्लियर अपोलो मिशन में वो लोग लाए थे कुछ वहाँ के रॉक्स एंड सॉइल एंड अदर। So this is the difference between orbiter and lander's activities.
Okay. Yeah, sir. Sir, next question with from Dr. Raghavan is if Earth's magnetic field lines affects the health of a satellite and how?
जनरली उतना इम्पैक्ट नहीं होता है क्योंकि बट जो डिफरेंट बॉडीज का वन बॉडी ओवर अदर जो ग्रेविटेशनल फोर्सेस है, F1, F2 and various combination of this thing. So that is more prominent compared to the magnetic effect of the Earth on the other satellites. The other physical forces are more prevalent or more dominant compared to the magnetic field effect on the जो इफेक्ट होता है वो मैग्नेटिक फील्ड से ज्यादा रेडिएशन का इफेक्ट होता है। जब सैटेलाइट वहां पे रेडिएशन एनवायरनमेंट में रहता है तो न्यूट्रॉन्स, फिर प्रोटॉन्स एंड अदर डिफरेंट टाइप ऑफ गामा रेडिएशन जो बॉम्बार्ड होते हैं वो सैटेलाइट की सरफेस को लेके अंदर के इलेक्ट्रॉनिक्स को अफेक्ट करते हैं, तो उसके कारण इलेक्ट्रॉनिक मिसबिहेव होता है। दैट इज द मेजर इम्पैक्ट कंपेयर टू ए मैग्नेटिक इफेक्ट। मैग्नेटिक इफेक्ट तो कुछ सेंसर्स है हमारे जो मैग्नेटिक टॉर्कर और उसके प्रिंसिपल पे वर्क करते हैं या हिस्टेरिसिस पे, वहां तक ही सीमित रहता है। बट मोर prevalent and more dominant are the interplanetary various bodies का जो impact है, but वो तो हम satellite fuel के मुताबिक उसका orbit maintain करते रहते हैं। That's why that thruster firing and all is for correcting the orbit of the satellite which drifts due to all these combined cumulative effect of all these forces. But magnetic का उतना impact नहीं रहता है। जो major impact रहता है for electronics especially is more due to the radiation of various types.
Thank you, sir. Large number of questions, people, and but we have to conclude now. And I definitely all the participants can ask any question on his email. It is done email. You can and you can ask any question anytime. It is. Very informative session we had, sir, and it was even for personally for me, I learned so many things about this communication and navigation satellites, and it's thank you very much, sir. Thank you again, sir.
Thank you, and sorry for exceeding my time. I am notorious for that.
No, sir. Thank you, sir. Thank you very much. It was very wonderful session, sir. And in fact, sir, I would like to inform you the same session we are going to use for the school student as well. Now we have recorded it in our place, and if you permit us, we will be using for school students also.
Yeah,
because
sure.
right now